Hello guys, uh, uh, welcome to this lecture. So in this lecture we'll be starting with the implementation of n-queen problem. Okay, so I think the previous lecture we have completed the manual concept of n-queen problem. What is exactly n-queen problem? And we also have seen very detailedly about how to proceed with it, but implementation is completely going to be very different because we have to use recursion, and the code is going to be very long also, because there are a lot of things that need to be done for this backtracking problem. Okay guys, but when you start solving 2 to 3 problems of backtracking, you will get an idea of how to proceed with it, because every backtracking problem will be having the same structure of implementation. Okay, the same functions we will have, the same structure we will have, and you have to just change the change the concept a little bit. Okay, there will be slight changes here and there. Okay, so we'll see the implementation. Hope so you will get a nice idea of how to get it, how to solve any backtracking problem. Okay, fine guys. So first of all, what I will just do is that I'll just take this this .c file. I will just take it. Okay, so we are going to start the implementation for a 4x4 chessboard. Then you can just alter it. Just you can simply change the value of n for it, and you can just proceed with for all the other configuration boards like 6x6 or 8x8 for everything. Okay, so first of all, what I will just simply do is I'll just take a variable called n, which is going to define the chessboard configuration, either 4x4 or 5x5 or 6x6. We'll just start with 4 cross 4. The present value of n is going to be 4, so n is equal to 4. Now, let me declare an integer array called as board of size n. Okay, so actually a chessboard is a matrix. Actually, it is a combination of rows and columns. But we are taking only a one-dimensional array, because to make memory efficient, so to give memory efficient solution, what we are going to do is we are going to take only a single dimensional array. I'll tell you how to use that single dimensional array for a chessboard to configure it as a two-dimensional matrix. How we are going to use it, that we will see. Yes. So before that, what we are going to do is, okay, we are going to write a function called as revert. Okay, there is a function called as revert we are going to write. It is not going to return anything, so the return type of this function is actually void. So void revert, and the argument that we require for this revert is simply the array. The array is going to be one parameter, and as well as the n value, that is the number of rows and number of columns of the board. Okay, so integer n. So why do we require this revert function, and why we are passing board and n value as a parameter to it? Because at some point of time, we have to, again, what we have to do is we have to just refresh the entire board, and we have to start for the next possibility. Okay, so what we have to, what for what purpose we are writing this revert function is to just erase all the present possibility and again start from first. So what we are going to do is that we are going to assign all the board array with all the cells with the value called as -1. Okay, so what we are going to do is we are going to write a loop, because there is only n cells in the array. It is a one dimensional array, right? So let us write a for loop. Int I is equal to 0, I is less than n, I plus plus. So for all the indices of the array, I'm going to just, okay, I'm just going to initialize all the indices of the array, that is board of every ith index. I'm going to place it with -1. What -1 is determining? It determines that that particular cell does not have any queen, or it does not have any coin. It does not have any piece of any chess piece. Okay, so -1 determines that that particular cell of the chessboard is empty. So when you do this revert function, when you implement this revert function, what will happen automatically? Okay, so that I will just tell you now. For example, we will take an Excel sheet. For example, let us take a 4x4 matrix. Okay, so this is going to be column 1. Okay, this is like, for example, this is like column 2, and this is column 3, and this is column 4, and this is going to be row 1, and this is going to be row 2, and this is going to be row 3, and this is going to be the last one is going to be row 4. Okay, so now what we are going to do is we are going to initialize the entire matrix as -1. Just consider like this, because we are not taking a matrix, we are taking only one dimensional array, but the purpose is to take the purpose. Okay, so we are going to just do something virtually actually, but let me explain the concept. Okay, so first is the very first step is that initializing -1 to all the entries of the matrix. Initializing -1 to all the entries of the matrix. Okay, -1, -1, -1, and all this matrix entries are going to be now -1. This is a very first step that we are going to do. First step that we are going to do, right? The next thing that what we are going to do is actually we have to start, placing the queens in the board. We have to start placing the queens in the board. Okay, so initially what we will do is, we have already in the basic, in the concept video, that is a previous video, I have already told you that queen 1 is going to be placed only in row 1. Okay, queen 2 is going to be placed only in row 2. Queen 3 is going to be placed only in row 3, and queen 4 is going to be placed only in row 4. So this we have a static, we have a that is, queen have to be statically, it should be inside row 1, any column of row 1. So queen 2 have to be in any column of row 2. Queen 3 have to be in any row of any column of row 3. Queen 4 have to be in any column of row 4. So this thing is going to be like static. So now you know very well that queen 1 is going to be placed in any column of row 1. So what we can do is, we can go for all the possibilities, right? Yesterday I told, in the previous video I told you that queen 1, let us start placing it in column 1, then let us move to row 2 and check where we can place it. We can check for all the possibilities. Okay, for every placement, how many possibilities? 4 possibilities are have, because when you take queen 1, then what is the possibility? If you can place it in column 1 of row 1, or column 2, or column 3, or column 4. 4 positions are there, 4 position possibilities are there. You can place q1 in any of this position, one position. Then suppose if you placed your q1 in column 1 of row 1, then where can the q2 be placed? Any one column of the row 2. The bounding function will come next, but possibilities, you can place it here, or either here, or either here, or either here. Then what you will do is, using the bounding function, you will check whether the queen 2 can be placed here, or otherwise here, or otherwise here, or otherwise. The bounding function will take care of whether it is the right place to place the queen. Okay, fine. So that we will just step by step, I will just implement, and then we will see the concept side by side. Okay, so let me first of all consider that I'm placing my queen in the column 1 of row 1. That is the first possibility that we can just look for. Okay, so 1 minute guys. Okay, so what I will do in this in the implementation side is that, so first of all what I have to do, first of all, for initializing, okay, for initializing all the entries to -1, we will be calling the function called revert function, and we will be passing the entire array called as board. Okay, and then followed by the value of n. Okay, so revert will automatically initialize all the board entries with -1. Then after that, what is the next step? The next step what we are going to do is, we are going to start with the possibilities. We are going to start with placing the we are going to start placing the queen in the matrix. Okay, fine, right. Okay, so now what we are what we have to do is, we have to understand that virtually we are going to see the concept in a 2-dimensional matrix, but this concept is going to be implemented in a single dimensional array. Concept wise we will see it using 2-dimensional array, but implementation wise you are going to implement in a single dimensional array. So how it is possible to achieve it? So that is what we are going to see now, right? So fine, so 1 minute guys. Okay, So we can also take a single dimensional array, and we can just, first of all, a single dimensional array called as board, and it is going to have four cells, right? 1 2 3 4. And what we are going to do is, already we have fixed that q1 is for row 1, and we have already fixed that q2 is for row 2, and also we have fixed that q3 is for row 3 and q4 is for row 4. Okay, so what we can probably do is that we can just have four cells, right? The first cell is going to define, that it refers to column 1. The second cell is going to refer to column 2. The third cell is going to refer to column 3. The next cell is going to refer to column 4. So which means, suppose if you are placing your q1 in column 3, it is indirectly understood that it is row 1 column 3, that is, you have placed your queen 1, right? Because queen 1 can be placed only in row 1. So if you are placing your queen 1 in column 3, it is indirectly understood that it is placed in row 1 column 3. That first queen is placed in row 1 column 3. Then with that information, we can probably cross verify whether the current place is the right place for queen 1 or not. So those things we can just cross verify. Okay, so taking that one dimensional array, column 1, first cell defines column 1, second cell defines column 2, third cell defines column 3, fourth cell defines column 4. By default, all these cells are initialized as -1. So I am showing you the two-dimensional view also, as well as the single dimensional view also. So based on that, we were going to decide how we are going to proceed further. So I have already told you that queen 1 belongs to row 1, queen 2 belongs to row 2, queen 3 belongs to row 3, and queen 4 belongs to row 4. So if you are placing your queen 3 in column 1, then it is clearly understood that you are placing it in row 3, because queen 3 belongs to row 3, right? So it is just to simply provide the number, the queen number, either 3 if you are placing here, it means that third queen is placed in column 1, which means third row column 1 you are placing it. So based on that data, you can check or verify that whether in column 2, in which row you can place the next queen. Okay, in a particular row, particular column, will you be able to place or not? That bounding function we will write separately, and we will check the queen can be placed in a particular cell or not. That we will cross verify, okay, using a bounding function. Okay, right. So now what I have to we have to start placing the queen, right? So how we are going to start placing the queen? Because the first row which place that we are going to place the queen, that we are manually going to decide, either in 0th column or in first column or in second column or third column, that we are going to decide. So totally how many columns we have? How many queens that we have? No, how many columns we have? We have 4 columns, right? So let me write a for loop for int I is equal to 0, I less than n, I plus plus. Okay, so inside this loop, what I'm going to do is board of I is equal to 0. What it means, that is, first time what I will do is, in 0th column I will place the 0th queen. That is, first queen only we are referring to as 0. So I think probably we can also change it here so that you can understand it better. So this is not row 1, this is going to be row 0, and this is going to be row 1, and this is going to be row 2, and this is going to be row 3, and this is going to be column 0, and this is going to be column 1, this is going to be column 2, and this is going to be column 3. Okay, coming here to the board also, if you see here in the board also, okay, 1 minute guys. Yes, fine. So in column this is not column 1, this is column 0, and this is column 1, and this is column 2, and this is column 3. Similarly, this is not queen 1, queen 2, queen 3. You can say that's queen 0, that is queen 1, and you can just take queen 2, and this is going to be queen 3. Right? So now you can understand it better. Right? So what you are doing is that initially in 0th index we will be placing 0. What it means, that column 0 we are placing 0. Column 0, if you are placing queen 0, what it means? In 0th row, 0th column, we are placing the first queen. Because queen 0 belongs to row 0. Okay, queen 0 belongs to row 0. So if you are placing it in column 0, it is clearly understood that it is placed in row 0. Okay, so you are placing your queen 0 in column 0. That is the first step that you are doing. Okay, so in column 0, you are storing your queen 0. Fine, right? Fine. So now what you are going to do is this loop will automatically, after finishing, okay, see, when you place your queen 0 in column 0, you will have some other possibility, queen 1 placing in some column, queen 2 placing. So after finishing checking all the possibilities, then you will automatically, you will come back to the same loop, and the loop will run, that is I is equal to 1, and automatically in one column you will place your 0th queen. The loop will move to index 2, and you will just, it will it will initialize 0 to your 0 to your second column. So it will, this loop will check for all the possibilities. Okay, so either placing the first queen, that is 0th queen, in either column 0 or column 1 or column 2, column 3, all the 4 possibilities this loop will take care of. Okay, and one more thing to do. Okay, so now you have to check all the possibilities, right? We are just initializing, we are just placing the queen, but you have to check whether all the queens are placed, and also you have to check whether a queen can be placed in a particular cell or not. All this checking process is there, right? For this checking process, we are going to write a separate function called the solve. You are going to write a separate function called the solve. I'll just simply write only the signature of it. That function will be returning as integer, that is either 0 or 1, because if it returns 1, then I can decide that this is completely a possible solution. Okay, that is, if you start your board, that if you start placing your queen from 0th column, if you get a, if you are able to place all the 4 queens in this particular board configuration, then it will return, that solve function is going to return you 1 if you got an particular possibility. If you don't get any possibility, it will return 0. So based on that 1 or 0, you will understand, this main function will understand that whether you got a solution or you don't get a solution, right? So integer, the function name is solve. Okay, so this function solve is going to have 3 arguments. First of all, the present board values. So first the array board. Next one, you will have something called as count. What this count is going to tell you? Count is going to define that row, that is queen 1 or queen, now which queen you are going to fill. Either queen 0 you are going to fill, or queen 1 you are going to fill, or queen 2 you are going to fill, or queen 3. So the queenth number which you are going to find, the current which queen you are trying to place, that queen number is going to represented by this count value. Then finally you have to give the n value, that is the total number of queen you are going to place. See, n also defines the board configuration, that is either 4 cross 4 or 5 cross 4. It also defines the number of queen that we need to place, because if it is a 4 cross 4 matrix, then 4 queens have to be placed. If it is a 8 cross 8 matrix, then 8 queens have to be placed. So n also defines the number of queen to be placed in the board. So these are the 3 parameters that I am going to provide for solve function. Okay, so here what I am going to do is I am going to call the function. Okay, wait, I am going to call the function called the solve function, and I am going to pass the 3 arguments. First one is board, array board, and the next one is count. What is count? I told you already what is count actually. So we will also write it in the comment line that board is equal to the chessboard. Okay, board means we are just defining the chessboard. Okay, the next one is count. So count, what it defines, count is defining that the present queen number. Okay, the present queen number that you are trying to place. So which queen you are trying to place now? Either 1th queen you will be trying to place, or 2nd queen, or 3rd queen, or 0th queen. So which queen you are going to try placing now, that queen number is what referred by count. The next one, n. See, I'm writing all these things because the code is going to be very long actually. So without this command line, you cannot understand it again, because I'm going to share the same code to you for your reference also. So for that understanding, I'm just writing which variable defines what, defined for what purpose. Now n is going to tell that how many, totally how many queens needed to be placed, how many queens needed to be placed. Okay, fine. So now what you are going to do is you are going to pass board. And what is count? Count means present queen number that you are trying to place. What is the present queen number that you are going to place? Already you have placed the 0th queen. Already you have placed the 0th queen in some place. Okay, either in the 0th column or in 1st column or in 2nd column or 3rd column, depending upon this loop actually. But you will place the 0th queen here in the main function. So what is the next queen that you have to try to place? 1th queen, because already 0th queen is placed. Now you should start placing your, checking where to place your 1th queen. So send 1 instead of your count, because always what you will do, you will place your 0th queen in the first row, any column you will place, and you will start your checking process from your first queen. That is what we are going to do. So that is the reason why I'm placing 1. I'm sending 1 instead of count. The next value of n, next value I have to send the original n. What is the n value here? 4. So I will be sending 4. You should have already known that for main function, there will be a different activation area created inside your random access memory, and for the solve function, a different activation area will be created. For the revert function, a different activation area will be created. So if all these 3 functions are having the same variable, you should know that based on call by value or call by reference, okay, you should decide. If it is call by value, definitely the 3 variables are different. This n variable is having a different memory location, allocated a different memory location. This n variable is allocated with a new memory location, and this n value is having a different memory location. So all these 3 variables are having 3 different memory location, which means that the name does not decide that whether these 3 variables are same. The activation area, and also either the call by value or call by reference methodology, the calling methodology, not call by reference, call by address. Okay, so either call by value or call by address defines whether the 3 variables are different variables or same variable. Okay, fine. So what I'm trying to say is that, so if you want the clarity about this activation area, or otherwise if you want the clarity of this call by value or call by address, you can just visit our channel 6 phrase MySlate, where we have basic C version as well as advanced C version playlist we are having. You can just go there. We have a separate section for section for recursion, where you can see this activation area. What is activation area? What is the behavior of activation area? Those things you can just probably look it out there. Okay, fine. So now you are calling this function, and I have already told you this solve function will either return you 0 or it will either return you 1. Suppose if this function is returning you 1, then it means that you got the solution. If it is returning you 0, it means that you don't get the solution. You have not still got the solution. So I have to check whether if this function call is equal to 1. Suppose if it is returning you 1, which means that you got the solution. If you got the solution, then you can probably display the present configuration. Okay, you will just display it. And also what you have to do, you have to display it, and you have to again, what you have to do, you have to just initialize all the values to again -1, and you have to start for the next possibility. Here comes the revert function, help of the revert function, because using revert function you can initialize all the board values to -1. So you can probably just simply call revert function instead of doing that process again and again, right? So what is the first thing? You have to display the present possibility. Then you have to go for again you have to initialize all the entries to -1, and you have to proceed it again. Okay, so first of all we have to write a function for displaying, but I think so now you cannot get a clear idea of how to do the display process, because you have taken a single dimensional array. First of all, you need to understand how the single dimensional array is going to be working, so that you can just write a display function. So that we will come to that display function later, but but what are the 2 parameters required for display function? First thing, board, and you have to tell how many cells are in the board. That is the 2 information required to display the board. So now I will just simply call the display function and I will pass the configuration, board configuration, as well as the total number of cells available. Okay, and then after calling the display function, let me call the revert function to initialize all the cells again back to -1. So I'm calling this revert function and I'm passing the board config. So what is the two arguments of revert function? One is the board, other one is the value of n. So I'm just passing board value and n value to that function. So which this function automatically takes care of initializing all the values to -1. All the values to -1, right? So now else suppose if that function is not returning you 1, if it is returning you 0, what you have to do? It means there is no possibility. So what you can do, you can go for the next possibility. The current possibility is not possible, so we can look for the next possibility. So to go for the next possibility, what you have to do, you have to initialize all the values again to -1 and they have to start. So if it is else also, you have to revert it. Okay, revert it and then you have to go. So I think what I can do is, I think we can write the revert function actually common, but for your understanding, I'm just revert function you can just write outside if else, because both in if else you are having revert function, so you can probably write it outside. Okay, but for your better understanding, that is what I'm telling the concept. For the concept to be very clear, I'm just telling you that if that function call is returning you 1, display the value, again revert back to the original, revert back to the default board values, then continue for the next possibility. Else if that function is returning you 0, also revert all your board values again to -1. Okay, board comma n -1, and then again start from first. Okay, fine. So the main function is exactly in place. Okay, so the next thing that we are going to do is we are going to start implementing this solve function. Okay, so first thing that I will tell you about the solve function. Okay, the very first thing that I'm going to tell you is that when we will return 1, when we will return 1. Okay, so we will return 1 if count. What is count? Actually the present queen that you are placing, right? So let me consider that you are placing queen 0. You are placed queen 0 in main function. Then you are placing queen 1. Okay, you found some place for queen 1, you are placed in somewhere. Then you also placed queen 2. Then it seems that you have also placed queen 3. Suppose if you fail to place queen 3, you will not move to next step, you will go back again, you will revert back to queen 2, because queen 3 does not have place. So you go back to queen 2 and you will check for a different position of queen 2. Okay, because for the present configuration of queen 2, you are not able to place queen 3 in any place. So what you will go back to queen 2, you will replace it, you will just change its position. After changing the position, then you will come back to queen 3 and you will search for a better position. You will find for a right position to place your queen 3. So if you are coming to queen 4, there is no queen 4, but first of all queen 0, then you move to queen 1, then you move to queen 2, then you move to queen 3, then you increase your count to queen 4, and when you reach queen 4, it means that already all the queen 0, queen 1, queen 2, queen 3 are placed. If you reach queen 4, it means that all the other queens are placed. Okay, if all the other queens are placed, what you can say, that all the possibility has been found. Okay, the possibility has been found. If the possibility is found, okay, if the possibility is found, what you will do? You will return 1 to your main function. That is, the solve function will return 1 to the main function. That is what I am clearly saying here. If that solve of board comma 1 comma n is equal to 1. So if count is equal to n, that is queen 4. That is if totally 4 queens have to be placed. What are the 4 queens? Queen 0, queen 1, queen 2, queen 3. So automatically when you enter queen 4, automatically it is understood that all the 4 queens are placed. So if count, what is count? The present queen that you are trying to place. Okay, that already we have written here, right? Present queen number that you are trying to place. So the present queen number that you are trying to place is actually 4 or exactly n. You can say that already all the queens are placed. So if all the queens are placed, you can return 1 to your main function, indicating that you got one possibility. Okay, you got one possibility of placing all the queens such that no queens attack each other. Right? Fine. Else, suppose if the count is not equal to n. So I think hope you understand why we are checking this condition. Okay, because this condition implies that all the queens are already placed. If all the queens are placed, then you got one possibility of placing n queens in this n cross n chessboard such that no queens attack each other. Okay, so now coming to this else function, what you have to check, which queen you are trying to place now, because already the 0th queen is placed in the main function. Now you are trying to place the first queen, that is queen number 1 you are trying to place. So the queen 1 can be placed either in column 0 or either in column 1 or either in column 2 or either in column 3. Am I right or wrong? So 4 possibilities are there for every queen to be placed. So you can write a loop that runs for 4 times, because you have to check. First of all, you have to check placing it in 0th column. Then you have to check placing it in 1th column. Then you have to check placing it in 2nd column. So I think yesterday you have seen the bounding, that function, that state space tree, right? For state space tree, what was there actually? For every node there was 4 subnodes available. For every node there is 4 subnodes available. So for any problem, if you are drawing a state space tree, then you have to find the number of subnodes for every node. If the whatever the number of subnodes available, that is going to be the number of time the loop that you are going to run inside this else function. Okay, for every problem you are going to write a loop like this, and this loop is for checking all the possibility, that is the number of subnodes of every node. Okay, the previous day, previous video, that we have drawn a state space tree for which every node is having 4 subnodes, which means that for every queen there is 4 positions it can be placed. So you should be running a loop, that is int I is equal to 0, I less than n, I plus plus. So you need to run 4 loop for 4 times, that is for n times dynamically, and you have to be checking whether the queen can be placed in either of this column or not. Okay, so now comes a game, bounding function. What is the bounding function? Bounding function will check whether a particular queen can be placed in a cell or not. The constraint, what is the constraint? No queens should attack each other is the constraint. So it is going to check the constraint. So one more function, bounding function we want, and that bounding function I'm going to name it as, that bounding function I'm going to name it as eSafe. Okay, eSafe is the name of the bounding function, and this bounding function will return as either 1 or 0. 1 means it is safe, that particular cell is safe, so you can place your queen in that cell. So this eSafe is going to return an integer value. Okay, that is either 1 or 0. And what is all the parameter that is required by this bounding function called as eSafe? What is this? See, these things have to be there in the this is the comment line of your solve function actually. So coming to your eSafe function, what are all the parameters? First of all, this function is actually the bounding function. We mean that actually we have been speaking about this bounding function in many places, and this is where we have reached to the bounding function. So what is the bounding function? So remember that what is the present count value? 1. Okay, present count value is 1. What is this I value? 0. What is this I value is telling me? That column 0, either we are going to place our queen. What is the queen number? Count is the queen number. So queen 1, in which column we are going to place? Either in 0th column or in 1th column or 2nd column or 3rd column. Which row? Because queen is 1th queen. 1th queen directly says that it is 1th row. Okay, so first of all we need to check. First of all we have to check in that is for queen 1 can be placed in 3rd row or not, or 1st row or not, or 0th row or not. So what are all the information required to check that? First of all, the very first information that you require, is the present board configuration. Okay, board. The next one, you require int count. What is the count? Count is the present queen that you are going to place, either 1th queen or 2nd queen or 0th queen or 3rd queen. The next one, present value of n. What is that? Total queen to be placed. Okay, So comma into position. What is position? The present column that you are trying to place it. Okay, present column that you are trying to place it. So we will have a clear idea. First of all, the first one, what is board? Actually, the board is indicating the chessboard. Okay, chessboard is what we mean by board. The next one, you have count. What is count? Already we have written here for the solve function also. Present. Okay, I think we can just probably copy the same count, and n is also the same. Okay, so n and count. What is the position? Is a new position, is a new parameter that we have. Okay, so POS, position. So what is position indicating? Position indicating the present column where we are trying to, okay, the present column where we are trying to place, okay, where we are trying to place the present queen. Okay, present queen. Okay, fine. Now coming to eSafe, how I am going to check whether the present queen is safe, the queen can be placed in the present column or not. Yes, we will now come for this, go to the Excel sheet for to find it. Already in column 0, row 0, you have placed queen 0. That is in the board, that is the 0th index, you have placed your queen 0 of the board. Now you are trying to place your queen 1. Queen 1 also can be placed in column 0. It can be placed in column 1, or it can be placed in column 2 or column 3. So now first of all we are checking whether that queen 1, that is queen 1, can be placed in column 0 or not. It cannot be placed in column 0 because already the same column is having one more element. Because if the same column, say 2 queens are placed, then it can easily attack each other. Am I right or wrong? Yes. So for that purpose, what we are doing, going to do is, we are going to check few conditions. We are going to check few conditions. Okay, fine. Okay, so we are going to check for which conditions we are going to return 1. We are not going to check for which conditions we are going to return 0. We are going to check for conditions where we are going to return 1. That is the possible configuration. First of all, the very possible configuration is, okay, first of all we have to start checking. We have to start checking if the present column does not have any other queen. So I have to be checking board of position. What position defines a column? Okay, so what is the column now? Column is now 0. Okay, so we will be checking board of 0. What it is having? Either -1 means empty. If it is not -1, then it is having some queen. So I am going to check whether the board of position is equal to -1. If it is equal to -1, then it is possible. If not, it is definitely not possible. So you can go for else condition, whereas in else condition you can directly return 0, because if the present column is having already a queen, then you cannot definitely place one more queen in the same column. Is it right or not? Because now what you are doing, you are trying to place this next queen in row 1, column 0, which is not possible, because if you try to place it here, then automatically there will be an attack, direct attack will be happening. You cannot place it. So now automatically what will happen? Okay, I think every step we will go and we will find one condition. Okay, we will go and find a position. See, for placing queen 1, this is not the right place. So we found also one condition. What is the condition? The present column should not have any other queen. So we will find 1-1 condition in 1-1 configuration. So we will just probably check for all the board configuration, right? So now queen 0 is not possible, right? Fine. So now what we are doing is, we have written 0. So if 0 is written, then what will happen here? You are going to return 0, right? So first of all, you have to call eSafe. That function still you have not called here in the solve function, right? So what you will do first of all is that you are going to call that eSafe function here in the solve. Okay, so I'm just calling that eSafe function, and for the eSafe function we have to be passing, you can see the arguments actually, board and then count and n and then position. Okay, so I'm going to pass first of all the board function, board array, and then we will be passing the count value, then we will be passing the present n value, and the position. What is the position? Position is defined by I, the present I, that is 0th column. Okay, so if this eSafe function is returning us 1, this eSafe function can also return us 1, and also it can return us 0. 0 means it is going to be the else part of this. Okay, else part of it. Okay, so eSafe, if it is equal to 1, then it is fine. Else what we are going to is the game. If it is safe, we will return 1. Okay, we will return 1. This returning 1 probably will go for your that main function. Instead of this main function, you have this if checking the condition 1, right? So instead of that, you will be returning 1. Else what you will do? Else what you are going to do? Okay, sorry, one thing is, before returning 1, what you are going to do is, if this is safe, if this particular position is safe, I can place the queen, right? Present queen in the present column, right? So board of what is the present position? I is the present position. So in that particular column, you can place the present queen. What is the present queen number? Count is the present queen number. So you can place your count in the present column, ith column. Okay, then after doing that, what you have to do? So you have placed your next queen. You have placed your first queen, that is the queen 1. If you place queen 1, what you have to do now? You have to try to check the next queen, that is queen 2. You have to go for the next possibility, queen 2. So which function is actually trying to place the queen? Solve function is trying to place the queen. Solve function is trying to place, this is a function where we are trying to place a queen. So what you have to do after placing the present queen, again you have to call the same function, because that function only is going to check for whether it is possible to place a queen or not. Here comes the recursive, because in the same function we are going to call the same function. Here comes a recursive strategy. So I am calling the same function solve and passing the present board configuration, because there is a change in the board now, right? There is a change in the board. You have inserted a new queen in a particular position. So the new board configuration, then count. What is count? Present queen number that you are trying to place. Already you have placed that 1th queen. Now you have to go for second queen, which means that count plus 1. So you are going to check for the next queen. So count plus 1 you are going to check for, and the present value of n. Okay, and if suppose if this solve function is working, you will return 1. Am I right or wrong? Okay, so because everywhere you have either return 1 or return 0 you will have. Okay, so what I have to do is I have to check whether this next solve function, subsequent solve function, is going to return us 1 or not. If it is going to return 1, what I am going to do is I will return 1 to the main function. If this function is receiving 1, then I will just return 1. Okay, fine. Else. Okay, else. That is not this, yes, else. So if this particular if condition is not true, that is the solve function, if it is not true, I will probably return 0. Return 0. Now come to the else function of this eSafe. If that is not a safe configuration, if it is not a safe place, what you are going to do? Okay, if it is not a safe place, that I'm not, see, 1 minute, please. See here actually, see, one thing that you have to do is, I'm not going to return 0 actually. I'll just tell you something. If it is safe, you will place the present queen in the present column, and you will again go for the next queen check using this solve function. Okay, what I'm just trying to check is, if this is not safe, if that particular position is not safe, what you will do? Okay, if it is, see, else, that is, if the next subsequent solve function is not true, what you have to do is, you will come back. If for example, I will just tell you back. See, if you know recursion very well, then you will understand what I'm going to tell. Okay, so for example, let me just try to tell you that if you are placing your queen in this place, if you're trying to place your queen in this place, okay, I think I'm just probably trying to place, so queen, some queen is placed here, queen 1 is placed here, then queen 1 is placed here, then queen 2 is placed here, and then you're trying to place your queen 3 here, everywhere you're trying to place, and nowhere you try to, nowhere it is possible to place your queen 3. So what you have to do, you have to go back You have to go back and you have to literally change here, because you have placed your queen 2 here, right? Now you have to change this to -1, and then you have to go to the next position and you have to check whether queen 2 can be placed here or not. So while you're coming back, so always if you see recursion is having two phase. One is ascending phase, that is it will come from top to bottom, and again it will go from bottom to top. So it will again revert back. So when it is reverting back, you have to change this queen value to -1. So for that purpose, what you are going to do is, here in the else, suppose if the configuration is not possible, if a particular queen is not able to be placed anywhere, then you just revert back using this else function, and the same board of I, you try to change it to -1 and then you proceed. Change it to -1 and then you proceed. Suppose, okay, suppose if the board configuration is not safe, you have to go to the next position actually. If it is not safe, if the particular position is not safe, automatically the for loop will increment it. You will go for the next column to check. So in the else condition, you probably need not to do anything. But if this for loop is actually over and still you don't find the possibility, finally you have to return 0. If the complete for loop is over, okay, and if you're not if you're not able to find the possibility, then automatically you don't find the possibility, return 0. Okay, so let me just be very clear. What you are doing is, you are taking a queen and you are trying to place it in either column 0, column 1, column 2, column 3, and you are trying to check that is it safe to place it in column 0, column 1, column 2, column 3. If that is safe function is going to tell you 1, then it is safe. Then you will place that queen, that is count is a present number of present queenth number. So the present queenth number, you are placing it in the present column and you are trying to go for the next queen by using the same function. You are recursively calling it. Suppose if that particular queen does not be placed in that particular any column, then you will have to revert back and you have to come back and you have to change the present position to -1, and then you have to go back. I will just probably explain this at the end. After finishing all this, we will go for one complete iteration. We will check and you will come to you will be very clear why we are doing this. Board of I is equal to -1. Okay, fine. So now I think the complete solve function is over. The only function that is left actually incomplete is that this is safe function. Okay, so now we will just come here. We tried to place your queen 1. We tried to place your queen 1 here in row 1. But what happens is, in the same column is having queen 0, your eSafe function is returning 0 because the same position is not having -1. If it is not having -1, it is having queen. It means that it is having a queen. So we returned 0. Because of that return 0, what happened? That position was not safe. So this if condition is not true. So if this if condition is not true, you will again come back to the end of the for loop and you will go back and you will increment the I value. What is the present I value? 1 is the new I value. What 1 is defining? That you are going to try to place the present queen in the 1th column. So you are again calling your eSafe function. You again go to eSafe function. Now what is your present column? Your present column is this column. That you are trying to place your queen 1 in this particular column. You are trying to place it here. Okay, fine. So now let us check. I think diagonally you have attack, right? How to prove that diagonally there is attack? Okay, so for that reason, what I'm going to just simply do is that what I'm going to do is okay, right? We will just see for the condition actually. See, suppose if the board of position is equal to -1, that is if the board position is equal to -1, that is that the present column is not having any other queen. I think the present column is not having any other queen. So this condition is true. So entering this condition, the first thing that I will check is that this, okay, so this queen can be either you could have placed in column 0 or column 4 or anywhere you could have placed. But let me tell you one thing. Suppose if you are placing your queen in a 0th column, okay, if you are placing it in your 0th column, okay, so what I will try to do is try to check is actually I will just try to check 1 minute. I'll just try to wait 1 minute. Okay, so the next thing that what we are going to do is we are going to check whether we are going to place a current queen in the 0th column or not. Suppose, let me just tell you, if you are placing your current queen in the 0th column, okay, for example, you placed your the queen 0, for example, I'll just say, tell you, suppose you are placing your particular queen, your queen 0 is not in column 0, it is in some other column. So you are trying to place some other queen in this 0th column. What you have to try is, there is no left side to be checked. So only the right side you can check. The right side also what you can check is the immediate column, the right side column you have, right? In this column, suppose if the queen is placed here in this particular column, then what you have to check is, you have to check for the right side, the next column. If the queen is placed here, the next queen cannot be placed in any of these 3 cells. Am I right or not? Because this cell diagonal attack will be there. The next cell you will have a row wise attack. If the next cell you have, then you will have a column wise attack. So it should not be in this 3 rows actually. If the queen is placed in the one of the queen is placed here, the next things should not have, these 3 cells should not have it. So if you are placing a queen in this place, in which queen you can place it here? Only queen 1 can be placed in this row, because this is row 1. Okay, so if queen 1 you are placing here, and what queen you can place it here? 0th queen, 1th queen, 2nd queen. So what will be the difference of this 1th queen and 0th queen? 1 minus 0, 1. 1 minus 1, 0. 1 minus 2, minus 1. So the difference of the present queen number and the next column queen number can be either minus 1 or 0 or 1. See, listen carefully. In column 0, you are placing queen 0, for example. So, no, okay, right. I think, no. I think let us consider that in column 2, you are placing your queen 0. Now, you are trying to check whether you are placing just placing your queen 1 in column 0. So when you are trying to place a queen, some queen in column 0, what you have to check is that what is the queen number that you are having? 1. You have to take that queen number and you have to subtract it with the next one, that is the position plus 1. Okay, so you can ask me whether if that position plus 1, that is the next column, if it is the present column only, we refer it by position variable, POS. Okay, suppose if the position plus 1 is having minus 1, you can directly say that you can place the queen. Suppose if the position plus 1 is having some other queen, then you have to find the difference of this queen. So 1 minus 0, 1, 2. All these 3 rows cannot be filled. So 1 minus 0, 1. 1 minus 1, 0. 1 minus 2, minus 1. So if it is third row, if you are placing a row in the third, it is possible because there is no direct attack, right? So if it is greater than 1, and if it is less than either less than minus 1 or greater than 1, then it is possible to be placed. But if it is the difference is either minus 1 or 0 or 1, then it cannot be placed actually. The difference between what? The present queen number and the next position queen number. Okay, so what we are going to do now is, I think let me change the configuration back actually. So I think we can just probably, 1 minute guys. Okay, so what you can just probably do is that you can just probably change the configuration. So before that, what we are going to do is yes, so you can just here, I think we have minus 1 here and we have queen 0 here. Okay, here queen 1 is not, we are trying to place queen 1 here, just we will come to know whether it can be placed or not. But the very first condition that we are going to write here is, if the present position is equal to 0, there is no need of checking to the left hand side, because there is no left, because we are trying to place it in 0th column. So there is no left side to check, you have to check only the right side. So if you are placing it in the 0th column, that is the queen, if for example some queen is placed. Okay, so what you are trying to do is that if position is equal to 0, first thing, if the next column is not having any element, then directly I will say it is possible. So if the board of position plus 1, if the next position is equal to minus 1 or otherwise, okay, or otherwise the present queen number which is counted minus the next column queen number. Okay, so the next column queen number is actually board of position plus 1. Okay, let us consider that count, that is a present queen that I am trying to place is 1. 1. 1 means in one row only we will place it. The next column, if it is having queen 3 for example, okay, queen 3 it can be placed in row 3. So 0 minus 3. What is 0 minus 3? 0 minus 3 is minus 3. So if the 0th queen is placed here, definitely the next queen 3 can be placed here, right? So there is no direct attack is going to take place. So what we are going to do is we are going to check that count minus board of position plus 1. It should be either greater than 1 or otherwise, okay, or otherwise the count minus board of position minus 1. Sorry, it is like yes, board of position plus 1. If that is less than minus 1, if any one of these condition is true, any one of this condition is sorry, if it should be, yeah, if any one of this condition is true, definitely it is possible. So we are going to return 1. Okay, else we have to return 0. If any one of this, if all these 3 conditions are false, then definitely this is not the safe position. Okay, fine. So similarly, what we will do is we will check whether this is, if it is a last column or not. If it is a last column, then definitely there is no right side. If it is a right side column, then definitely, if it is a last column, then definitely right side you cannot check, only you have to check the left side. Left side, what you will do, if the queen is placed here, one queen is placed here, then the next queen cannot be placed in these 2 directions, these 2 cells. If the queen is, you are trying to place a queen in this cell, then you should not have any queens on these 3 cells. Diagonal, left diagonal, right diagonal, and in the same row also you should not have any queen. Okay, so what we are going to do is that else if, okay, else if the present position is equal to n minus 1, that is the last column. If it is the last column, what you have to check is the first condition is this. First condition is the immediate left side column. If it is empty directly, the same procedure. Okay, but the slight changes, instead of checking the right hand side, you are going to check the left hand side. Okay, so if board of position minus 1, left side I am checking. If the board of position minus 1 is equal to 1 or otherwise, okay, count minus board of position minus 1. If it is greater than 1 or otherwise, okay, or otherwise, count minus board of, okay, position plus 1. Position plus 1. It has to be less than, minus 1. If any one of this condition is true, definitely it is possible. So you have to be returning 1. Okay, so then else what you have to do, else we have to return 0, right? Okay, what is the next thing we are going to check? Okay, the next thing that we are going to check is the else condition. That is, else means it can be in the intermediate column. So if it is not first column, if it is a 0th column, we have checked this differently. If it is the last column, we have checked differently. Else means middle column. Middle column means you will have to check on the left side as well as you have to check it on the right side also. Okay, so how we are going to check it actually, right? The first thing is if the left cell and the right cell, if the left column and the right column, if both are empty, we can directly say that it is a right column. So what is the left column actually? Board of position minus 1 equal to minus 1, and at the same time board of position plus 1, the right side column, if that is also equal to, if both the things are empty, then I can just simply return 1. Okay, this is not the only condition to be checking. So else if now I have to go only towards the left cell. I'm going to check only the left cell. Okay, so left cell, what I'm going to do is I'm going to check if board of, okay, if board of position minus 1, okay, that is a left cell, left column, if it is equal to minus 1, and at the same time, okay, left cell is empty, and at the same time right cell, if you see right cell, it might have there is some, see, there is a different possibility. I will just tell you. If you have to place a particular cell, if you have to place a particular queen in the middle column like this, if you have to place a queen here, left column also empty, right column also empty, directly you can place. Or otherwise, left column can have a queen and the and right column can be empty. Or otherwise, the left column can be empty, right column can have queen, or both the columns can have queen. So there are four possibilities. One possibility is both the cells can be -1, that we have already checked. Second condition, left cell can be empty and the right cell can have a queen. If the right column is having a queen, what we have to check? Already we have this condition, right? Count minus. So if the right cell is having a queen, then you have to check that whether count minus right cell, right? So board of position +1, right column. It has to be greater than 1 and or otherwise that count minus board of position +1, it should be less than -1. Okay, if this condition is true also, you will be returning 1. Okay, so what you have tried is, one thing is both the sides -1, one thing is left side is empty, right side is having queen. Now the third condition, the next condition is going to be else if, okay, else if right side empty, that is the board of position +1 is going to be empty, that is equal to -1, and at the same time count minus, you have to check the left cell. Now left cell means board of position -1. So count minus board of position -1 can be greater, it should be greater than 1, or otherwise count minus board of position -1, it has to be less than -1. It has to be less than -1. Okay, so if these conditions are true, then you have to be probably you can return 1. Right? There is one more else if condition. What it is? Both the sides can have queen. If both the sides are having queen, then you have to probably combine these two conditions and check. That is this count function and this count function, both you have to combine and check it using AND condition. So what you have to, the next condition is going to be else if we can just probably take this condition. Okay, this condition have to be true, and at the same time this condition also have to be true, because both the sides are having queen. So this both conditions have to be checked. So if this both conditions are true, you will return 1. Suppose else, if any of these conditions are not true, then I will probably return 0. There are a lot of conditions in place. So what you have to work it out is, you have to take a matrix and you have to work on this condition, because it is not the conditions that you can understand at the first attempt. You have to cross verify all this conditions one by one. You have to sit and work, and then you just probably question. If you have any doubts, you can just can just respond it in the Telegram. Okay, after looking into the solution, then probably I can just help it out. Whenever I just look at your message, I can just probably reply it out. Okay, fine guys. So if else if, okay, all these conditions are perfectly checked. Okay, so else condition you have come with it, and this is the else condition for that if board of position is okay. For which condition does it? Okay, fine. So this if condition is like that is the else condition for this board of position equal to -1. So the complete safe, this is the bounding function. The very important place is this bounding function. So the entire bounding function you have completed. The entire bounding function is actually completed. Okay, fine. So now what you are going to do is actually now we can just go for display. I think so far we have not given display, right? So first of all, what we will do is we will just write a void display function. I think this is have to be a different okay, so I can just write it probably this place, because you have a comment line, right? So void display, what does display require? Already we said that we require the board array, and also we require the total number of queens. Okay, so before coming to this display, this display, I think we can probably check for one condition. We can just check for one configuration. Okay, so probably if you take like this, so placing your queen 1 here, placing your queen 1 here, which of this condition will be true actually? You can just probably take it here. So your queen 1, you are trying to place it in column 1, that is your position is 1. Okay, so first of all you will enter into this E safe and you will check that board of position. What is the board of position? Board of position means board of 1. What is board of 1 is having -1, so it is equal to -1, so I will enter inside. Now, is that position equal to 0? No, the position is not equal to 0. The position is 1. So, position is not equal to 0 and the position is not also equal to the n minus 1, which means that it is a middle column. It is not a first column, or it is not the last column. So, you can probably go to the else condition. Yes, here comes the else condition. Else condition is having 4 conditions. So, what is the first condition? Board of position -1 is equal to -1. So, board of position is this and board of position -1 is here. Board of position -1 is not equal to, it is not equal to -1. So the first condition is failed. So your position -1 cell is not -1. So you have to go for the else if condition. What is the else if condition? Board of position -1 equal. No, board of position -1 is not equal to -1. Go for the next else if condition. What is your board of position +1? Yes, your board of position +1. The next column is -1. And there is one more condition, and condition. There is the count variable. Yes. So count minus board of position -1. Board of position -1, what it is having? 0 it is having. So board of position -1 is 0. So 0, what is the present count value? Present count value is 1. Okay. So 1 minus 0. What is 1 minus 0? 1. That 1 is not greater than 1. Okay. There is one more OR condition to be checking. What is that OR condition? Count minus. That is count is 1 minus board of position -1. Again it is 1. 1 is less than -1. No, both these conditions are not true. So it will return 0. So 0 and 1, it is going to be 0. So this condition is also not true. Coming to the next one. Okay, coming to the next one. So count minus. So already we know that this condition is not true, right? So if this condition is not true, okay, if this condition is not true, definitely this one of this condition will never be true. Okay, I think probably we can ignore this condition because already here also you could have checked this condition here and you could have checked this condition here. But okay, fine. So because of this condition is false here, this count minus board of position -1 condition is false. Here also you have the same condition. So any one of the condition will definitely be false. So this condition is also not true. So you will come to else part where you are returning 0, which means that this is not the safe position because there is a diagonal attack. How did you find that is a diagonal attack? Because you are trying to check whether is there any elements on these 3 cells actually. Is there any elements on these 3 cells? If there is no elements on these 3 cells, then definitely you can place it here. Right? So queen 1, this is not the right place to place your queen 1. So what you could have done? You could have moved your queen 1 here to the column 1. So you will be now, you have to check here. Yes. So what you will check here now? You will first of all check whether the current position is having -1. Yes, the current position is having -1. Then whether the position is 0? No, we are not trying to insert anything in position 0. Now, is it -1? No, it is not n-1. Then you come to else part. Now you are going to check whether the both left side and the right side is -1. Yes, the both left side as well as the right side is -1. So it is very clear that you can place your queen in the center column. So now it is possible to place here. So E safe I have written you 1. So that what will happen if this E safe function is returning you 1. If the E safe function is returning 1, what you will do in the board of I? What is the present I value? 2. That 2 you will place your count. What is the count now? 1 is the count value now. So you will probably place your queen 1 in this place and you will again call the same solve function for the next value of countum +1. Okay, and then you will go for the next queen possibility. Okay, then you will go for the next queen possibility. So the thing that you have to check here is that the condition. Each and every condition you have to know for which purpose we have written this each and every condition. Okay, so probably just work with these conditions and then come back to me if you have any doubt in any specific condition. You can post it in the Telegram group that saying that this condition I have a doubt, this condition I have a doubt, so that I can just clarify it for you either in the comment section or in the Telegram group, 6-phrase Telegram group. Okay, fine. So now what we are going to do is still one more function is still pending. What is that function? Display function. So let me check that. Let me just come to a conclusion that suppose for example, if the queen 0 is placed here in column 1, okay, then, okay, let me consider that the queen to 1 is placed here in column 3. Then the queen 2 is placed here in column 0. Then column 2 you have placed your column queen 3. So if this is one configuration that you have got, okay, how you are going to display this one? How we are going to display this one? Okay, first of all, I will just check. Okay, I'm going to write a nested loop for printing the board in the matrix configuration. So int I is equal to 0, I is less than n, okay, then I plus plus. Similarly, you write for int j is equal to 0, j less than n, and j plus plus. Okay, so now what we have to do is that we have to check that j what I'm going to do is every time j I'm going to check whether if the jth cell is having I exactly. If jth cell is having I, that is initially 0 it is having, then this is a particular column in this row 1 which is having the queen. All the other cells we can probably mark it out with hyphen or hash something. Okay, so what we are going to do is that we are going to check if board of j, okay, board of j is equal to I. If board of j equal to I, then this is the cell where the queen have to be placed. If this condition is true, we will be printing that this is the place with queen 1, that is percentage d, comma, what is a queen value? I mean 0. I think we can just place it actually 1 2 3 4 3 4. Instead of having 0 1 2 3, we can have 1 2 3 4. So instead of that, instead of just printing I, I'm just printing I plus 1. Okay, so it will print either queen 1, queen 2, queen 3, queen 4. So I'm just printing this statement. Okay, and then the next cell, what I'm going to do is else if this is not true, that is if that is not equal, then we can probably for empty space we can just define it by hash. If a particular row is over, then I can print a new line character to print all the entire next row in the next row, that is in the new line. Okay, okay, so the display function is also over. So what are all the functions that we have done so far? We have done revert function, then we have done display function, then we have done esafe, which is bounding function, then we have written solve function, and then there is a main function. Okay, so all together now we will just check whether we get the configuration or not. Okay, is this fine or not? Okay, so new terminal. So this we have just saved it in this desktop. So gcc, oh, okay, yeah, fine. So gcc hyphen o hello, that is for the output file. For the object file I'm keeping the name as hello, and the name to be compiled is actually n queen problem.c, right? There is a expected semicolon at the line 43. Just go to line number 43. Yes, return 0, you have to place a semicolon here. Yes, fine. So we will again go with it, the compilation. Okay, it's just checking for the syntax. Yes, all the syntax is okay. So now we are going to go for the execution. Hello, right? Okay, fine. Okay, 1. Okay, fine. I think there is a mess up. Okay, fine guys, 1 minute, just give me 1 minute. So if you check that we have done a mistake in this condition actually. So if the last column is we are just trying to place it in the last column, we said that we have to check the left column. Okay, left column means board of position -1, but here unfortunately we have just given position +1, which is just checking the right side column, right? So that is the one mistake that we have done actually. So we can just probably check it out, and we can just go for one more time. We can just go for the compilation. Okay, we can just probably go for the compilation, and we can also go for execution also. We can just go for the execution also. So now if you can able to see that there is two configuration. The first configuration we will just check. The first configuration, the queen 1 is placed in row 1 column 2. Okay, queen 2 is placed in the last column of second row, which is fine because there is no diagonal attack, because row 1 and then you have it. I think it will be probably easy for you if there is any space is provided. Actually, space is provided. Okay, so between every configuration, after displaying the first configuration, I think probably we can have a new line character to differentiate it. So there is a new line character we have to print here, and between every thing that is in the display function, we can, between everything, we can just probably give out a space. We can just save it out, and now we can just probably go for one more compilation, and we can also probably go for execution also. Yes, we can able to see now very clearly that the queen is placed, queen 1, queen 2, there is no check here because it is not diagonal. Actually, diagonal is this is completely diagonal. Okay, and queen 2 is placed here, queen 3 is placed here. Queen 3 does not attack queen 2 or queen 1, and as well as it does not attack queen 2. Then the queen 4 is placed here, so queen 4 does not attack all the other queens, so it is in the perfect combination. The next combination is like queen 1 in third column of row 1, and queen 2 is in the first column of row 1, row 2. And similarly here you can just see that in the previous video we saw that there is only two possibilities, and the same possibility you can just cross verify. We have got that those two those two possibilities here as the output. Okay, so what we have done here in the implementation is that what you have to just study is, because it's a very it is a very long implementation actually, which is like 137 lines of code. Okay, so now what you have to just first of all concentrate is that first of all you should understand why we have given this why we have just starting with this loop. You need to understand that, and then you need to understand this why we have to place this else condition. Then you need to understand why we are just checking this safe function, that is a bounding function. And then you should understand each and every condition that is imposed here inside your safe function, that is the bounding function. So each and every function. Okay, so probably what you can do is take a note, pen and paper, start writing each and every configuration, and just come here to this safe function and check for the condition, and the condition will match any one of the condition. Any one of the condition will match, and then you can just, okay, for this condition we have placed this one. Okay, fine. Right, okay guys, thank you, and this is it for this this is it for this lecture. Okay, so any other clarification that you want, you can just probably reach out to me. Okay guys, thank you guys. Yes, before just closing out this session, I want one more thing that is required to be clarified actually. That is the analysis of this particular problem. That is either that is the time complexity of the problem have to be discussed actually, right? So in the next video, the subsequent video, I will just give you a video for the time complexity. Okay, all right, we will just have an analysis of time complexity and space complexity. The next not in the next video, the same video. Okay, so just wait for some minute to just continue with the time complexity and space complexity. Right, thank you guys. Fine, thank you.